welcome. This is a presentation about some best practice, but you won't see most of the command configuration and etc. as you watched my presentation. As Boris Wątki is in this room, one additional question before we start. Did anybody on this room raise the hands if someone saw my presentation about BGP black holing? Yeah. So essentially you can leave. Okay, that was just kidding. Welcome everybody, just joining the room. The agenda is very simple. We can start with analyzing the event that led to this presentation. Then we talk about some of the best practice, and then hopefully there will be time for questions and answers. Another quiz at the very start. Did anyone of you know what happened on the 24th February of 2008? Please raise your hand. The guy was here. Okay, what happened? You can switch to Polish, I can understand. Well, that was sort of good answer, so here's the award. But actually I was looking for this answer, and as I have as a sponsor another gift, I would like to ask another question. What else did happen on 24th of February 2008? Another people raising the hand. What else happened? Yeah, that was the good question, guy from Home PL. But actually I was looking about this answer. So if you could come, or I will walk. That's another way of doing the presentation. When you go into the crowd and look for the people. Okay, let's look at what really did happen. What really did happen was that Pakistan Telecom guys tried to black hole the YouTube traffic because it contained censored content. So they implemented the BGP black holing idea. However, they skipped my presentations and they didn't make it right at the very start. Unfortunately, it reflected throughout the whole internet. They made a very simple error. However, the upstream operator did make another one, which was accepting the prefixes without any checking of the prefixes and sending them throughout the internet. So at the very end, throughout few hours of internet time, we had a situation in which traffic from any source in the internet going through the IPs belonging to the YouTube address space were sent to the Pakistani Telecom. When you look to the BGP Play tool that's available on the right side website, you can see that this is a very useful tool for tracking changes in the BGP advertisements. Short question, does anybody doesn't know what the BGP protocol is? Hopefully nobody raised a hand. Yes, some sort of. So when you look at the tree and what does it actually mean, is that we have Pakistani Telecom guys here, that's that red dot here, and we have YouTube guys here. And for normal operation, those guys are advertising the prefixes and those guys are receiving the traffic throughout the internet. That's the normal situation. We can look for the Ahmed, we can look for the Yezhin Zbajin. What actually did happen was that the guys attracted a lot of traffic to their own network. Effectively, denying any internet access to the Pakistani telecom intranet, but that was not the problem, just only for them. I couldn't watch Ahmed, so that was my problem. If you didn't see the BGP Play tool, and you are either a service provider or somebody connected to service provider with knowledge about what the BGP protocol is, I highly recommend that you look at it because it's freely available. You can just log in onto the website and look for the changes, play with the tool, and see what it can do for you. Actually, there is a movie that is showing the slow progression between that picture and that picture. When you see some of the providers still didn't receiving the update from the Pakistani guys, and some of the guys receiving it and slightly changing the traffic matrix throughout the internet. This tool actually also shows what autonomous systems were in the path of the advertisement throughout the internet, so you can quickly check who's accepting what and from what, actually from what source. So another comment about the outcome of this tool is that most of the service providers, as you see here, were just accepting the prefixes without any checks. Of course, you can argue if it's possible, at least for the transit providers, but we'll go to that in a moment. So there's very simple tool, there's a very simple best practice that can be implemented to stop something that did happen for the YouTube. Actually, when you have two routers or the peering between two routers and the BGP protocol, you can usually install prefixes filters to filter for the incoming traffic, and it's regarded as one of the best practices to use in the internet. Of course, it's very simplistic. You have one router, single prefix list about 1,000 lines long, and you say, okay, that's still possible to maintain it. There are tools throughout the internet, throughout the various reels, and you can listen about them just by going to the registry authorities' websites and look for the tools that can automate the process of distributing the prefix lists throughout the routers if you have many of them. Of course, there are also some mechanisms in place to automatically update the prefix lists. That's out of the scope of the presentation. What happens if we don't have such mechanism in place? What we saw with the YouTube, at least one site that's accepting everything from the peer which is connected to, and we have a situation in which probably we'll have some problems with reaching the prefixes in the original destination. It can be regarded as a just question of the network management. It can be regarded as of course, as a security threat, because we can hijack the traffic through some, for example, electronic bank, listen to all the traffic, and redirect the traffic to the original bank to still be able to establish the session and etc. So it's kind of sniffing in the internet, so eternal for the L3 networks. And as you see, one site just advertises the prefixes or doesn't prohibit advertising of the prefixes, and probably will have a problem imminent in a whole internet because we have some prefixes leaking from the ISS. And from time to time it happens most of the time actually, but usually the not so highly traffic engaged websites are targeted, so you don't see the problem with Ahmed or anybody else on the internet daily. However, if you watch for the network operations mailing list, you will usually see at least weekly who's announcing a prefix blah blah blah, because I'm seeing it on my routers. So watch for this. So what actually went wrong? People were the weakest link, as always. I can assure you most of the guys did spend a lot of time watching the best practice presentations, attending the workshops. However, at the end of the day, they did make some some mistakes during the configuration of the routers. What we can do to prohibit it from happening in the future? Probably not much, because at least from 4 or 5 years, most of the service providers are trying to influence everybody around to use some mechanisms, to use some tools to automate and protect the prefixes announcements in the internet from happening the errors like it was the case with the YouTube. However, there is no standard way of distributing the information. As you see on the slide, and you probably know if you know the BGP protocol, the design is decentralized. There's no single source of information what the BGP word table should look like. If you have 2 internet providers for your own router and you take the full feed of the 260K of the prefixes, about 260 prefixes, there will be slight differences in both of them. So this is the way the BGP protocol should work. For the people in the community, in the service provider community, there is always a need to establish a connectivity that is above all other contracts. So usually there are non-formal communities like NSPsec that can take people from authorized people from service providers, and they can work on the problem if the problem is happening just like now. And actually the community NSPsec was used during the YouTube problem. First, the guys from the YouTube started announcing more specific prefixes to try to catch the traffic to themselves. Then the guys from the Pakistani Telecom were contacted at least after a few hours, and they tried to back up the configuration. Okay, that was for YouTube. But here in Poland, we're the best, yeah? No, we're not. Actually, when you have the full feed from most of the service providers in Poland, you usually will see RFC 9018 prefixes feeding throughout the prefixes. Why? I don't know why. You can always check with your service provider why it is announcing those prefixes. One serious note about this slide, probably most of you did notice, of course the autonomous system numbers were Xed for protection of the innocent, is the problem we have here. What's the problem? The problem is that prefix is not the prefix that is transiting the service provider network. It is originated in the service provider network. So apart from some honeypots and honey nets, I can believe that most of the service providers are using them. Probably some of the networks are used for management, are used for things that should not leak to customers or should not leak to other service providers. But you usually see them, so you can probably scan some of this network space and find some very interesting information throughout the network. If you ask me, I didn't show you that slide. Okay, so just very short, going through the best practice and doing it by the book, how it should be done. At the end of the day, when we have IP packet and it's on the internet because somebody sent it, it has to be either rejected or it has to be delivered. So from the service provider perspective, we are delivering the packets. Are most of the packets, or all of the packets, needing the equal treatment? No, of course no. Most of them probably will be needing differentiated service classes and should be either sent or queued or buffered or maybe dropped. Why I'm showing you this slide? It has nothing to do with technical part on one side, and it has everything to do with the technical part on the other side. If you have bright guys in your service provider network and you're really working hard to to establish the connectivity and work 24 hours a day, 365 days a year. If you don't have the procedures in place, probably at the very first event when you have some incident, security incident, network management incident, you will have to spend time that is not usually needed, because you will lose your either focus of just will try to look for the information. So the very first assumption when you are looking at any best practice is to write a document or procedure that is documenting who should be doing what in the event of whatever. Do we have any Americans in the room? Hope one. Oh, okay. I'm not trying to pinpoint you. There's of course a long saying in Polish that usually when Americans are trying to do something, they have to write it for themselves, because probably they will lose the focus during the reading. But it's very unfortunate truth that when the people are under the pressure of something big happening, they lose focus. So when you have it on the paper, or you have it on the intranet, whatever, and it's detailed list of things you should do and you shouldn't do in the time of the crisis, it's always good to use it. Okay, so before we start the hardcore configuring of the routers, switches, and all the optical stuff, this is the old world of the service providers. Unfortunately, some of the service providers are still living here. We can reach their own networks, we can scan the networks, they are claiming those are the security incidents, etc., etc. The new world of the service providers is the world where the service provider network, the network itself, isn't reachable from the client perspective. That's the very essential thing to do when you are trying to separate your own network from the network of your customers. If you do it right, probably nobody will be able to directly attack your network. That's the first good point. And the second point is, you can then spend a lot more of time to introduce some best practice in your network, because you have time not to spend on incidents, but you have time to spend on the network management part. Then we can go to the layer 2, layer 3, and layer 4, work on the more specific examples. For example, we can go to best practice, any number you like, and try to implement them one by one. That's a very good idea to do. Unfortunately, again, some of the service providers are just skipping the checks because they are basics. Okay, we are so advanced, we'll just go through the filtering of the AS path, and then making of the very long regular expressions to filter out the hijacking of the prefixes. At the end of the day, someone injects the RFC 1918 address space throughout the service provider network, and probably can destabilize the whole network itself. Such incidents happened in Poland in the past, and I'm afraid it can happen in the future. Okay, so what can we do? Before we can go into advanced stuff, I delivered a lot of presentations about, let's say, advanced stuff. Traffic engineering, things like filtering the prefixes, things like going into the working of the IP routing and checking if every node in the network, every autonomous system is doing exactly what we are trying to do. But unfortunately, most of the service providers, I'm not only talking about service providers that are big, mind you. There are a lot of let's say, wireless service providers in Poland. There are a lot of condominium service providers in Poland. A lot of them are always service providers, but at the end of the day, they also skip those checks. So for the BCP 84, which is the actual BCP for the ingress packet filtering, because the new RFC just was updated some time ago. One of the very essential things is to stop the spoofing of the IP addresses. When you stop the spoofing of the IP addresses at the edge, you have, again, a lot of bandwidth free throughout your network and can work on the serious problem, not the very basic ones. I was delivering a session about 3 years ago in Poland on Confidence or SecureCon, when I said that IP spoofing in Poland is, well, highly improbable because most of the providers, most meaning 99% of them, that was my knowledge at the time, had the filters in place to stop the spoofing. Unfortunately, it isn't the truth. Service provider networks migrate. You are connected to a lot of different service providers when you switch the homes, when you switch the locations. There are always free wireless LAN hotspots on your favorite cafeteria and things like that. There's a very interesting project about checking if the address space is spoofable and from where it is spoofable. Those guys are trying to contact the service providers and inform them that the traffic can be spoofed from their own network. And in Poland, we have a bunch of examples when service providers are permitting the spoofed traffic throughout their own network. Most of the traffic is blocked at the very edges of the outer edges of the network. Unfortunately, if someone is connected other client, and you can assume there are many clients. You are one of them, but there are many clients of the service provider network. You can still try to attack or spoof the IP addresses during the attack to that client. And actually, we saw some attacks using spoofed address space in the wild. So short statistics: 16.5% of the net block space is spoofable, translating to IPv4 addresses about, if I'm counting the digits right, it's about 78 million of IP addresses, of unique IP addresses. That's still address space that can be limited when you are looking for the incident, security incident or network management incident, and you can help yourself with some automated tools to decipher the output of the logs. Still quite misfortunate. So what can you do to put the spoofing to rest? You can use URPF, preferably URPF. That's the name used throughout a lot of platforms, a lot of vendors. So it's not a very one vendor specific. Cable source verify DHCP. That's essentially URPF for the cable modems, for the CMTS systems. And if you have Metro Ethernet networks, if you have those condominium ISPs, you can use you can use functionalities that are on those boxes, on those switches, routing switches, whatever you call them. Very simple thing. However, as I said, I delivered a lot of presentations about more advanced stuff, and at the end of the day, we see that the very simple things just simply fail. Again, where to react? You should react at the edges. If you react at the edges, at the every edge of your network, throughout to customer, connected to customer, or connected to another SP, you still have chance to manage the traffic. If you just leave a one point of insertion of the spoof traffic or malicious traffic throughout your network, you have the problem in your whole network. Without good monitoring systems, without good anomalous monitoring systems, you will have a hard time hunting the traffic throughout your network and minimizing the collateral damage. So we can see one of the routers is connected to two upstreams, and we filter here. One of the routers is connected to Internet Exchange Point. We also implement the PCP practice on this router. I'm not saying all other routers should be left in the default config or whatever you call it. Yes, they should also have those checks in place. Depending on the configuration, depending if, for example, MPLS is running, here, maybe they shouldn't be at all touching the unlabeled traffic going through the service provider network because of the transit. So when you look at the advanced blah 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 presentation, best practice, etc., most of the cases people that are daily spending time working with the cases where such incidents take place, most of the people say use very simple mechanisms in place to prohibit the escalation of the problems. So when you see something like this, most of the people will say there's a KISS principle. KISS meaning keep it simple, stupid. Not stupid you, stupid because it's very simple. And when it's very simple, it can be used during the stress of the actual incident. Okay, that was the network management. Now we can move to the security, because the security is also part of the problem that probably hits the service provider when you have some problem like this. So when we move from one side of the very, very best simplicity configs and things like that to more advanced stuff, at the end of the day we usually see stuff that is running in the application layer, or at least layer 4. So please don't skip mentally those slides I showed you a minute ago. But very interesting thing happened here as far as current internet is running. IP anycast. IP anycast or IP black holing, most of the users of the technique is usually already using anycast. Can I ask for raising the hand of the guys that work for the SP? Any SP? Oh, that was the session for the SP. Okay, anycast is great because there are 2 users, and from both of the users you can learn a lot. First use is distributed monitoring. You can inject that, you can influence the traffic to come to your workstations running Wireshark, TCP dump, whatever, and listen to the binary log of the network traffic and look for the traffic that is destined to IP addresses that are not yet used. Maybe that they are assigned to you, maybe they are advertised as a part of the bigger network, but they are not used. Simply speaking, you can usually see a lot of scans, a lot of tries to exploit the non-existing machines, because we are trying to search the whole space that is used. The other use is to load balance the traffic. From perspective of the small SP, medium SP, and big SP, usually you have problems scanning the bandwidth or performance of the services you are advertising to your clients. So the most of the traffic usually is directed at your DNS servers. Those are the clusters that need to answer millions queries per second. And actually there is a known technique to load balance the traffic throughout the DNS system. It was used in the defense of the root DNS systems back a year ago. So essentially you can just assign or advertise one IP address, assign that IP address to many physical machines, put them around your network in the places where it's easy for the client traffic to go into your network, and then you have perfect load balancing between the machines. If one of them fails, there are still advertisements to the very same IP address throughout your network, and clients can reach clients can still reach the IP address. So this is one of the techniques. Black holing or sink holing, meaning you have specially prepared or crafted network, workstations, whatever you call it and whatever you do with it, and then you redirect the traffic going through either a target, because it's, for example, DDoS DDoS attack, or maybe some traffic that is of very interest to you. For example, the traffic to the gray space, meaning the not yet used the IP addresses. Some of the at least 20 or 30 projects, security projects throughout the internet you can find using the Google, are using this technique to track of the botnets or other Trojans, etc. Most of the, for example, most of the antivirus vendors are using this technique also to track of the new viruses. So you are trying to attract the traffic and then advertise the IP addresses or advertise the whole net blocks if you can aggregate them, and then listen what's going into those prefixes to check if there is imminent problem with it. And of course, as I said a few slides before, you can scale the services. Usually the service is DNS because it's stateless. You send one UDP packet, you receive one UDP packet, there's no state. So even if I have one client here and I do a query, if I'm querying this server and probably one of the DNS servers will respond, I'm not caring which one of them, you still do understand the reply. Of course, we have a lot of DNS stuff that is bound to security stuff, so signed sessions, signed zones, things like that. That's very okay, and we are okay with that. But if you are trying just to keep the DNS traffic balanced, or whatever traffic balance, if you can make it stateless, then the Anycast Sinhole traffic will work. Another question is the stability of your network under the DDoS attack. This is the screenshot example of some web portal, management web portal. If you have proper account on a proper system located somewhere in the world, you can see that very easy web management portal for starting the DDoS attack. For all of you that are not native Russians, this means Statistica. Statistica means statistics or statystyka po prostu. You can see that for the statistics of this botnet administration portal, you have 35,000 of hosts under your control, out of which only 2,300 are actively online and available. Small, but very handy. You can even have statistics for the countries in which the botnet clients reside, so you can check if you have it in your own country. And then the prices are also very attractive, so you can pay with the stolen credit card for launching the DDoS attack just by using your favorite web browser. You have the favorite order now button here, so just go ahead. Unfortunately, we don't have Poland here, but it's just a screenshot of some web browser. For all of you that don't understand Russian, this is ceny, which means prices. Actually, you have the prices in dollars, so that was not that hard. Another question for the best practice of the transiting traffic or accepting the traffic from your customers is the raise of the encrypted peer-to-peer application traffic. Of course, we can argue that peer-to-peer application traffic can be used to exchange unauthorized content, let's say. Most of us, all of us, of course, are using it to download favorite ISO files of the Linux and BSD distributions. We don't use any other operating systems. But at the end of the day, this is a very serious problem because we have a lot of networks that are trying to provide the anonymous or anonymizer services to the clients. Some of the services are even under some prices, so you can buy them as a service. And there is a lot of commercial companies that are using those services because they are working on projects that don't need to specify from which IP address space or from which host some type of activity was started. So the problem is service providers first of all should deal with the problem of encrypted traffic. And what's the problem is? When you are accepting the encrypted traffic and you will be tasked by some organization, either government or your contractor ISP, because you just signed a contract with USP, to track what was the source of the traffic and can you show the traffic to some authorities, there's a lawful intercept keyword, which means some functionality in your boxes that can sniff either the whole traffic or samples of it on either on demand or full-time or as a full-time job. And that's simply because there are some laws that require you to do. The other problem is when you are transiting the traffic or accepting the traffic and you can't identify what the traffic is, you can go to the problem. You can approach the problem in two ways. I'm not caring what the traffic is. It still fits into the service. So, for example, a customer paid for 2 megabits per second access and it's using 2 megabits per second access. I'm not intervening into the traffic. That's okay, of course, unless you are trying to fight some distributed denial of service attack, and probably or most of the adjacent SPs are targeting you as a source of the attack, and then you should answer the question if that is DDoS traffic or not. And the other approach is to just say, okay, I will try to control the encrypted traffic to know what's going on in my network. So I will do a lot of classification stuff at the very edge of my network and see if I can inspect legitimate internet protocols and pass the encrypted traffic to separate queue to track the usage of the bandwidth. We have a lot of DDoS attacks currently running in the internet that are low bandwidth attacks. You have botnet members that are sending 1 packets in a second, and this is any traffic that leaves the client. Unfortunately, when you scale it, for example, for 2 million of bots, it makes a difference. 2 million packets per second is quite a big. So you should always, as a service provider, you should always try to think from this perspective. Even if I don't care what happens, if I will be needing to care what traffic is transiting my network. So, of course, there are commercial solutions to this problem. Some boxes that claim that you have perfect visibility about the traffic that is inserting into your traffic. Most of the boxes are modified Linux boxes with some proxies, SSL tricks and trips, so not always working as advertised. However, this is one of the approach to the problem. Don't ignore it, try to work around it, or at least try to dip into it. There's a very standard solution also, very beautiful solution at the end of the day, that doesn't necessarily mean mapping those QoS things into the traffic. It's standardized because it's RFC, and it's very simple. When you are sending evil traffic to the network, just mark it as evil. If you are sending friendly packets, just mark it as 0. That was the slide that should provide me with some ha-ha-ha, but I see that all of you are reading the RFC still. Guys, I was joking. This is the 1st of April RFC. From year to year, IETF agrees to publish the RFC that is bogus, however contains some very interesting stuff. How many of you did believe that this is very true RFC? Okay. How to learn to think outside the box. There's no magic way. There's no magic procedure to do it. Try to read. At the very end of all my presentations, I show a lot of links and I show a lot of books to read. Unfortunately, this is still the case. If you are close to any knowledge that's available on the internet or outside sources, you are probably missing a lot of information that can benefit your operations or can benefit your knowledge as a network SE or service provider. So there are ISP security essentials that cover also not the security but the management stuff. There's a packet clearinghouse site. Those guys are working as advisors for various service providers, and actually those guys invented, let me say that, invented in quotes, IP Anycast to protect the DNS service. Anybody was from the networking perspective, anybody was aware that there's something called Anycast IP, useless because well, it doesn't provide any services, but those guys just say, okay, let's try to use it to offload the traffic from the stateless services. And it worked. Most of the SPs in the world that are providing some DNS services and other services are using already the technique they described a few years ago. And of course, a lot of books. If you read a lot, probably you will see some interesting stuff. Apart from things that are available both in print and an electronic version, there's Michał Zalewski's book Silence on the Wire, very enlightening in very big amount of aspects. And there's of course Tao of Network Security Monitoring, so covering the aspects of how to get most benefits from the traffic you are seeing or from the statistics you are looking at when you are trying to get sense of the network you are operating. And that's all. Any questions? That was fast. 45 minutes. Once again. With what? Sorry, I don't hear you. Yeah, to the slide with? This one? Some slide that I did never show? Whatever. Okay, any other questions? Okay, thank you very much.
Okay, thank you.
Czy mogę cię poprosić do siebie? Can you go in?